Hello and welcome to a quick video. We're solving simultaneous equations where we have one quadratic and one linear equation today. Unfortunately, the method that we use for solving simultaneous equations where both of them are linear doesn't work for this. What we need to do is substitute something in. So the first thing I'm going to do is rearrange the linear equation so it says either y equals or x equals. I'm sure that here we can see quite easily we can make that say y equals 3 plus x. And all I've done there is added x to both sides to get y on its own. So step 1 is to rearrange the linear equation to get y equals or x equals. Step 2, what I'm going to do next is substitute this in to the quadratic. Because I know that y is equal to 3 plus x, whenever I see y, I can write 3 plus x instead. So 3 plus x is equal to x squared plus 3x. I'm allowed to do that because y is the same as 3 plus x. Now at step 3, we're going to solve the quadratic. And we can use any of the methods that we've learned, completing the square, using the formula, or factorising. If you remember, the key is to make it equal 0. So I'm going to have x squared plus 2x minus 3 equals 0. I've taken away the x and the 3 from both sides. Now we can factorise this to x plus 3, x minus 1 equals 0. So I know that x equals minus 3 or x equals 1. Now what I need to do is substitute those two values into the linear equation to find y. So when x equals minus 3, y is equal to 3 plus x. If you remember, we had that up here. So y is equal to 3 plus minus 3, so y equals 0. So one set of solutions is that x equals minus 3 and y equals 0. Now when x equals 1, y is going to be equal to 3 plus 1, so y is equal to 4. So our other set of solutions is x equals 1 and y equals 4. And if you think about it, the reason that this happens, the quadratic graph would be a curve, would be a parabola, and the straight line is normally going to cross it twice. So our final step there is to substitute in to find the other value. So let's just have a look at another example. We'll do the same again. We're going to rearrange one of these to say either x equals or y equals. Now this is going to be easiest to do x equals, so we'll do that. So again, we'll substitute this in. So 8 minus 2y squared plus y squared is 52. And again, I'm allowed to do that because 8 minus 2y is the same as x. So if I square that, I'm still doing x squared. Now remember, be careful here. X minus 2y squared means that you have to write it, you've got the same bracket twice. So here I get 64 minus 16y minus another 16y plus 4y squared plus y squared is 52. If I rearrange this, I'll get 5y squared minus 32y plus 12 equals 0. And this factorises to 5y minus 2, y minus 6 is equal to 0. So again, I get two possible solutions. I can have y is equal to 2/5, or I can have y equals 6. And we need to have answer for x for both of those. Now we know that x is equal to 8 minus 2y, so x here would be 8 minus 2 lots of 2/5, which is 36 over 5, and here x is going to be 8 minus 2 lots of 6, which is minus 4. So I've got two pairs of solutions. I get x equals 36 over 5, y equals 2 over 5, and our second solution is x equals minus 4 and y equals 6. And even when they look a little bit more complicated like this one, the same method is going to work. I'm going to rearrange this so it says x equals, so 3 minus 4y is equal to x. Then we're going to do exactly the same as we've been doing before. I'm going to substitute that x into the other equation, so I get 15y squared plus 24 plus 3 lots of 3 minus 4y, and that equals 10y plus 3 minus 4y squared. So again, all I've done is replace the x with 3 minus 4y. So let's multiply this out so we can start working with it. 15y squared plus 24 plus 9 minus 12y is equal to 10y plus 9 minus 24y plus 16y squared. Now, so I can keep that y positive, I'm going to move everything from the left hand side to the right hand side. So I have y squared minus 2y minus 24 is equal to 0. And that factorises to y minus 6, y plus 4 is equal to 0. And exactly as before, I'm going to have two possibilities here, that y is equal to 6 or y is equal to minus 4. And we know that x is equal to 3 minus 4 lots of y. So x is equal to 3 minus 4 times 6, or x is equal to 3 minus 4 times minus 4. So here x would be equal to minus 21, and here x would be equal to 19. So again, I get two pairs of answers, x equals minus 21 and y equals 6, and x equals 19 and y equals minus 4. So if we have simultaneous equations with one quadratic and one linear, it's always a case of substituting in. Rearrange one of the equations to make it say x equals or y equals, substitute it into the other one, solve the quadratic, and then use that answer to find the remaining unknown. I hope that helps. Thanks very much.